What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, find the value of x for which x minus 5 all raised to the power of log 5x minus 25 is equal to 2. Well, our first step is to factor this expression. So we have x minus 5 all raised to the power of log. Now, looking at this expression, you notice that 5 is common. So we can factor out 5. So now 5x divided by 5, that's x, minus 25 divided by 5, that's 5. And this is equal to 2. Now notice that I have x minus 5 here, and I also have x minus 5 here. So we can apply substitution here by saying let x minus 5 be equal to m. That means wherever I see x minus 5, I'm going to be putting m. So this expression becomes m to the power of log 5m equal to 2. Our next step will be for us to take the log of both sides. So I'll take the log of the left-hand side. It becomes log m raised to the power of log 5m. And I'll also take the log of the right-hand side, which is going to be log 2. So log 2. Our next step will be for us to apply the law of logarithm, which says, for example, when I have log a to the m, this can be written as m log a. You notice that we use the exponent m to multiply log a, which is what we have here. So we're going to be applying this law of logarithm to this expression on the left. Take the exponent, which is log 5m, and multiply that with log m times log m equal to log 2. Now, our next step will be for us to apply yet another law of logarithm to the left-hand side. For example, the law of logarithm says when I have log a times b, which is ab, this is equal to log a plus log b. Well, this law of logarithm is called the multiplication to addition law of logarithm. And we'll be applying this to this expression here, log 5m. So let's write log 5m like this. So this becomes log 5 plus log m. So we've been able to achieve log 5m in this form. And remember, this is multiplied by log m. So let's multiply this expression by log m equal to log 2. Our next step will be for us to open up this bracket. So log m times log 5, I have log 5 log m plus log m times log m, I'm going to be having log m squared equal to log 2. Now notice that we have a quadratic equation in log m. So our next step will be for us to rearrange this equation so that it looks easy to solve. Let's do that in the next slide. So on rearranging, we're going to be having log m squared plus log 5 log m log 5 log m. Now as log 2 crosses to the left, becomes negative log 2 equal to 0. So in order for this to look good, we can just say let log m, which is this expression, be equal to y. That means wherever we see log m, we're going to be putting y there. So this becomes y squared plus log 5y. Remember, this is log m, which is y, then minus log 2 equal to 0. So we're going to be applying the quadratic formula to solve this. You see that a is equal to 1, and that's the coefficient of y squared. B is equal to log 5, which is the coefficient of y. So this is log 5. And C is a constant term, which is negative log 2. So negative log 2. So the quadratic formula we're using is y, since we're looking for y, is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and substitute this inside of this quadratic formula. So this becomes y equal to negative b. B is log 5 plus or minus the square root of b squared, that's log 5 squared, minus 4ac. 4 times a times c. 4 times a is 1, so 4 times 1 is 4, times c is negative log 2. So we have 4 times negative log 2. Let's extend this a little. So all over 2, because this means 2 times 1, a is 1. So that is 2 times 1 is 2. Our next step will be to simplify this log 5 and also work on this minus and this other minus. So we have y to be equal to negative log 5 plus or minus the square root of, now log 5 is same as log 10 divided by 2. And this is raised to power 2. Now minus times minus gives plus. Then 4 times log 2, we have 4 log 2 all over 2. Our next step will be for us to apply a law of logarithm to what we have here, which says when I have log a divided by b, this is equal to log a minus log b. So this is the division to subtraction law of logarithm. And we're going to be applying this to this expression here. Let's do that in the next slide. So now let's apply this law of logarithm to this expression. So we have y to be equal to negative log 5 plus or minus the square root of, so this can become log 10 minus log 2. And this is raised to the power of 2 plus 4 log 2. So 4 log 2 all over 2. Now we could also recall a law of logarithm which says that the log, let me just write recall, that log 10 is the same thing as 1. So let's write 1 here instead of log 10 because they are actually the same thing. So we have y to be equal to negative log 5 plus or minus the square root of, so this becomes 1 minus log 2. So 1 minus log 2, and this is raised to power 2 plus 4 log 2. 4 log 2 all over 2. Now, our next step will be for us to expand what we have here. So this becomes y equal to negative log 5 plus or minus square root of. Now, expanding this, I'll have 1 squared, that's 1. Now, 2 times 1 times negative log 2, that's negative 2 log 2. And negative log 2 squared, I have plus log 2 squared. You see that? Cool. Plus 4 log 2. Let's extend this a little. All over 2. So y becomes negative log 5 plus or minus the square root. Now, simplifying this, you see that we have 1. Now, let's work on this and this. So this is negative 2 log 2 plus 4 log 2. I'll have plus 2 log 2. And then plus log 2 squared all over 2. Now notice that this expression is a perfect square. So we have y to be equal to minus log 5 plus or minus the square root of. Now, like I said, this is a perfect square of log 2 plus 1 to the power of 2 all over 2. Let's continue in the next slide. Now notice that the square root can cancel the square so that we have y to be equal to negative log 5 plus or minus what I have here, which is log 2 plus 1 all over 2. Our next step will be for us to separate the plus and the minus. So we have y to be equal to negative log 5 plus, going with the plus first, log 2 plus 1 all over 2. So I'm going to be calling this case 1, case 1. And now for this other one, I have y to be equal to negative log 5. This time we go with the negative, so use the minus to open up the bracket. Minus times log 2, I have minus log 2. Then minus times plus 1, I have negative 1 all over 2. So I'll call this case 2. So we're going to be working with this one after the other. So for the first case, so let's call that case 1. This we have y to be equal to negative log 5 plus log 2. Now plus. Now 1 is the same thing as log 10. So I'm going to be writing log 10 here all over 2. Now remember the law of logarithm we used, multiplication to addition. Well, the reverse is also the same. So y is equal to, so wherever we see addition, we apply multiplication there. So we take the common log outside. Now you see that this and this are multiplying. So this gives 2 times 10. That's 2 times 10. Now divide by 5 because this is minus. Minus associates with division in logarithm. So divide by 5 all over 2. So this becomes y equal to log 2 times 10 is 20. So 20 divided by 5 is 4. So this becomes log 4 over 2, which simplifies into log, well, 4 is the same thing as 2 to the 2, which is 2 squared, all over 2. And easily, applying the law of logarithm, I can take this 2 behind the log 2, so that I have y to be equal to 2 log 2. That's taking this 2 behind the log 2, which is what I did, according to the law of logarithm, all over 2. So we see that 2 can cancel off 2. So the value of y is equal to log 2 for the first case. Now let's move on to the second case, which is this. Now for case 2, you notice that negative is common. So we can factor out negative so that we have y to be equal to factor out negative. Now, negative times negative gives positive log 5. Now, negative times negative gives positive log 2. And then negative times negative gives positive. And like we said, 1 is the same as log 10. As it all over 2. Now, we're going to be applying the addition to multiplication law of logarithm. Remember, the reverse is always the same. Either addition to multiplication or multiplication to addition. They are the same. So y now equals to negative. Now take the common log and multiply the expressions. 5 times 2 times 10 all over 2. So that y becomes negative log. Now 5 times 2, that's 10, times 10 is 100 all over 2. Well, this can simplify into negative, well, log 100 is same as 10 to power 2 all over 2. And now applying the law of logarithm, take this exponent to the back so that we have negative 2 log 10 all over 2. So 2 can go with 2, leaving y to be equal to negative log 10. So, well, if you don't want this negative behind, this is actually negative 1 because there's an invisible 1 here. So this can also be written as taking what is here to become an exponent, it becomes log 10 to the power of negative 1. It's still the same thing. So this is what we have for case 2. Now recall that we said log m is equal to y, right? Cool. Now let's start with case 1. So for case 1, we have log m to be equal to the value of y for case 1 is log 2. And in order for us to get the value for m, we're going to be taking the anti-logarithm of both sides. So this can be written as 10 to the log of m equal to 10 to the log of 2. And remember, from the law of logarithm, the base here of this log is 10. And as long as this base is the same thing, 10, that means they cancel off, leaving just m. So let me write it here. Let me write it here. So here leaves m to be equal to, now the same thing happens here. The log and this 10 cancels off, leaving just 2. So the value of m is equal to 2. That is for case 1. Now let's move ahead to case 2. Now for case 2, recall that log m is equal to, the value we have for y for case 2 is equal to log 10 to the negative 1. And now taking the anti-logarithm of both sides, this means 10 to the log m equal to 10 to the log 10 to negative 1. So this goes off, leaving m to be equal to, this goes off to be equal to 10 to the negative 1, which is also written as 1 all over 10. So we've been able to get two cases. The value of m for the first case, we got it to be 2. And the value of m for the second case, we got it to be 1 all over 10. But the question requires us to look for x. Remember that we said x minus 5 is equal to m. Now, going with the first case, let me say case 1, that's when m is equal to 2. So x minus 5 is equal to 2. So get the value of x, we move negative 5 to the right hand side so that we have 2. As negative 5 crosses to the right, it becomes plus 5, making the value of x to be 12 for the first case. And now for the second case, case 2, that is where we have m to be equal to 1 over 10. So we have x minus 5 equal to m, which is 1 all over 10. So this becomes x to be equal to 1 all over 10. As negative 5 crosses to the right, it becomes plus 5. So x will be equal to, now let's use a shortcut, 10 times 5, that's 50. So 50 plus 1 is 51. So this is 51 all over 10. And this is our second answer. So we have two values for x. X is equal to 12 and x is equal to 51 all over 10. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.